Hello, and welcome to this video about why do ionic compounds form. We're talking about Chapter 7, Section 2. If you haven't seen the video for Section 1 yet, I suggest you do so because it goes over the two crossed off bullet points as part of Target 1. Mainly it talks about how to draw Lewis dot structures and how to determine the number of valence electrons, and how we use Lewis dot structures to explain how cations and anions form. In this video, we're going to be talking about ionic bonds and how they form and their overall charge of the resulting compound, and then also talk about the properties of ionic compounds. So let's go ahead and get started. What is an ionic compound? Well, simply put, ionic compounds are just when a cation and an anion combine together. Okay, there are neutral compounds between a cation and an anion, the key word here being neutral. Even though cations have a positive charge and anions have a negative charge, your ionic compound overall is neutral. Okay, some examples of ionic compounds that you might have at home right now are baking soda, and of course the most obvious one, sodium chloride NaCl, which is table salt. Here the cation is Na, sodium, and the anion is chlorine. Okay, recall that metals, which is what a sodium atom is, you tend to form cations, and anions tend to form nonmetals. So that's something to remember as we move forward. An ionic bond is what forms an ionic compound. Ionic bonds are between cations and anions, or we can say between a metal and nonmetal. Okay. Ionic bonds form because of the opposite charges that attract each other. Okay, so an example is sodium, which has 1 valence electron, and chlorine, which has 7. To gain stability, sodium will probably lose that electron, and to gain stability, chlorine will want to gain one more. When it loses this electron, sodium becomes a positive charge. When it gains one, chlorine, with a full outer shell, has a negative charge, and this negative and positive attract each other to make NaCl and bond between the two. And so we can say that NaCl, or cation and an anion, probably has some chemistry together, and that's why they're coming together to form a compound, an ionic compound with an ionic bond between them. If we're going to do another example, let's say we had calcium with 2 valence electrons and oxygen with 6 valence electrons. Okay, calcium probably wants to lose 2 to gain stability. Oxygen wants to gain 2. What results is that calcium has a positive 2 charge, oxygen has a negative 2 charge, and they attract each other to make CaO. Okay, let's do one more. Let's say we had lithium and oxygen this time. The oxygen has 6 valence electrons, lithium has 1, and actually I'm going to change this to potassium because that I having a dot bothers me a little bit. In this case, lithium or potassium wants to lose 1, and it's going to become a K with a positive 1 charge. Oxygen, to gain stability, needs to gain 2. It wants 2. So where is that other electron going to come from? Okay, it's probably going to come from another potassium atom. That's going to give up one of its electrons and become a K+. And then oxygen, after gaining 2, will be a 2- with 8 valence electrons. And so all of these three things will come together to form K2O. Now you're probably wondering where this K2O came from. Ooh. Okay. And we use CaO or K2O to talk about and represent compounds that are ionic versus their individual atoms. So chemical formulas would be the CaO or the K2O. And they're used to represent when two atoms or more than two atoms are combined together with a bond. The formula units indicate how many of each atom there are. So in the case of K2O, this would be the formula unit indicating 2 potassium atoms bonded to oxygen. Okay, you might have seen something that is H2O. Okay, this is 2 hydrogen and 1 oxygen. Even though there's no 1 there, okay, it's kind of implied, but we don't need to write it. Okay, now my question to you is this an ionic compound? So come in tomorrow prepared to answer that question if you watch the video. Okay, how do we represent an ionic compound versus individual atoms? Okay, let's go back to our sodium example. NaCl would be an ionic compound, and remember that compound are 2 or more atoms bonded together. Okay, well, Na by itself will just be a single atom. And an atom, remember, is just an atom. It's just one thing. Okay, so you got to be able to differentiate between a compound and an atom and be able to tell them apart. And we use the formula unit to do that. So what are some of the properties of ionic compounds? And they're pretty cool. The first being they have high melting points. If you ever try to melt salt by itself, not dissolved in water, it's going to be pretty hard because they have a high melting point. They are solids at room temperature. Okay, salt is solid at room temperature, so is baking soda. The cool thing is that when you melt or dissolve it in water, they conduct an electric current. Okay, and I'm gonna show you that tomorrow with a demo. So by now, after this video, we are able to explain how ionic bonds formed with Lewis dot structures and describe the properties of ionic compounds. There are 3 of them. Okay, and here we use Lewis dot structures to explain how NaCl was formed. Okay, so your task for tomorrow, besides that one question I asked about water, H2O, is to write a summary in 10 words or less that answers our essential question. Other than that, have a great night.